Everything in our visual world has colour. Colour defines the seasons and tells us when to stop and when to go. Colour affects our emotions. It can be warm or cold, exciting, passionate, and even boring. It's estimated that we can distinguish over 9 million colours, and our eyes are more sensitive to greens than violets. This DVD takes a new approach to the understanding of colour. For the first time, three-dimensional graphics enable the viewer to fully understand all dimensions of colour. There are many examples to illustrate traditional colour theory, together with complete explanations of contrast types, terminology, and colour harmony. There is also a guide to colour mixing, colour bias, and effective palette selections. We suggest you watch the entire DVD to get the big picture. Then you can use the menu and select the chapters you want to review. First, let's take a brief look at the science behind colour theory. When we pass sunlight through a prism, the colours of the rainbow can be seen. They are a part of the electromagnetic spectrum and emerge from invisible ultraviolet through violets, blues, greens, yellows, oranges and reds, and then disappear into the infrared. But how does colour come about? Why are these tulips red and pink, and why are the leaves green? Different surfaces absorb and reflect light in different parts of the spectrum. Black surfaces absorb nearly all of the colours, while white surfaces reflect them. Blues occur because all colours except blue are absorbed, and other colours come about when the rays are absorbed and reflected in different combinations. As artists, how do we make sense of the universe of colour? Is it possible to paint the iridescent colours of this peacock feather? How does one mix the red-violet tints of this dahlia? And what colours should one mix to paint a scene from nature? To answer these questions, we need to understand the principles of colour mixing. Light and pigments have different colour properties and give very different results when mixed. In stage lighting, red, blue and green are the pure colours. When red light overlaps blue light, the result is magenta. Blue and green mix to make cyan, and green and red will yield yellow. When all three overlap, white light is the result. This is called additive mixing and is principally used in stage lighting as well as for TV screens. The mixing of paint and pigments is called subtractive mixing. This time it's yellow, cyan and magenta which are the base colours. We get reds and oranges from mixtures of magenta and yellow. Blues and violets arise from combinations of cyan and magenta, and when we mix yellow and cyan, the result is green. In theory, black results from the combination of all three colours. In practice, we get dark grey. We see these principles at work when we look at a colour print. To achieve this result, the printer first makes an impression of the yellow, then the magenta is printed over the top, then the cyan, and finally a grayscale is added to give the image stronger contrast and depth. Note that there is no white ink used. White is the result of the paper underneath showing through, similar to a watercolour painting. The colours are printed in screens of tiny dots of varying sizes, which overlap one another. This creates an optical mixture of colour, which disappears when the image is viewed from a distance. The small size and proximity of the dots trick the eye into blending the colours together. Low-quality prints, such as old newspaper or packaging, will have relatively coarse screens, while the printing of a good quality art book will have very fine screens and may even use additional colours such as light cyan and light magenta. Inkjet computer printers work in a similar way. These test marks were found on the inside flap of a biscuit box. In addition to cyan, magenta, yellow and processed black, a violet and a scarlet have been added for the printing of block colour. The optical mixing of colour was exploited by the Impressionist and Post-Impressionist painters. Painters such as Monet and particularly Seurat placed small dabs of pure colour on their canvas, which blend into other colours when the painting is viewed from a distance. Essentially, when we look at the world around us, we can think of colour in three different ways. For example, in this still life, we immediately identify the small bowl as white, the vase as black, the cup as blue, the lemon as yellow, and the tomato as red. This is known as local colour and describes the colour of objects seen in white light. The same scene in red light is very different. The white bowl is now pink, the cup violet, and the lemon is orange. This is known as optical colour and is typified by the colours the landscape takes on in hazy conditions and at sunrise or sunset. Now the colours of the objects have been changed randomly and without regard to local or optical colour. This is called arbitrary colour and is typically used by painters when expression is the priority. This painting is a good example of the use of arbitrary colour.